High up in the Andes Mountains, where the air is thin and the winds are cold, there is a mystery carved in solid rock, where enormous blocks of stone sit fitted together with a precision that defies simple explanation. Some weigh dozens of tons, others weigh far more. There is no mortar between them, yet many of these walls have remained standing for centuries, shrugging off earthquakes, harsh weather, and the relentless passage of time. Places like Sacsayhuamán, Ollantaytambo, and Puma Punku hold some of the most jaw-dropping stonework ever discovered anywhere on Earth. When you walk through these sites, it isn't just the staggering size of the rocks that catches your eye. It is the way they were shaped. They aren't stacked in straight lines like modern bricks. They are carved with strange, complex angles that lock together like a giant, perfectly fitted puzzle. Picture what it would actually take to build these places from scratch. We are talking about moving stones that weigh up to 100 tons, without machinery, steel cables, or even wheels. The builders had to drag these boulders from quarries miles away, pulling them across raging rivers and up sheer mountain cliffs. It is a building project so incredibly difficult that it would make modern engineers break out in a cold sweat. To really understand these ancient megastructures, we have to step back from the simple history we were taught in school. We have to look past the famous Inca Empire and follow a trail of clues much deeper into the past. Now sit back, relax, and grab a snack, and settle in as we begin our journey. When we picture ancient South American mysteries, our minds naturally drift toward towering stone fortresses hidden deep in the clouds. We imagine heavy walls and massive carved blocks sitting high up in the freezing Andes Mountains. But some of the most profound archaeological puzzles are not made of giant stone, and they are not found anywhere near the famous highland empires. To find one of the most brilliant structures ever built in the ancient world, we have to travel down to the western coast of Peru. Here in the Pisco Valley, the landscape completely changes into a vast and sweeping desert. The air in this valley becomes incredibly hot, and the ground turns a pale, dusty yellow. In this harsh environment, early people had to carefully manage their food and water just to survive the dry seasons. Long before the famous empires rose to power, the Pisco Valley was home to highly organized groups of people. While some neighboring cultures are famous for drawing giant geometric lines in the flat sand, the builders here left behind something entirely different. They decided to carve directly into the rocky side of a steep desert hill to create a feature known as Monte Sierpe, or the Band of Holes. If you walk right up to Monte Sierpe on foot, the site is very confusing and hard to navigate. You are immediately faced with a steep rocky hill covered in thousands of shallow circular pits. Researchers estimate there are over 5,000 individual holes carved into the uneven ground. These pits range from 3 to 6 feet wide and are carefully lined with small rocks. Walking among them feels like climbing a dangerous and unstable rocky hill, where the holes do not look like a single connected structure. Early explorers who walked the site often thought they were looking at ruined storage bins left behind by a small farming village. For decades, researchers struggled to explain why an ancient culture would spend so much effort digging empty holes in the harsh desert dirt. Some early excavation teams suggested the pits were intended as graves for a nearby town. They assumed the stone linings were meant to protect buried remains from the harsh desert wind. However, when archaeological teams actually dug into the soil inside the pits, they found 0 human remains or burial items. Other researchers proposed the holes were used to store water for local farming during the extended dry seasons. That idea quickly fell apart because the sandy soil of Monte Sierpe drains water almost instantly. The sand makes it completely useless for long-term liquid storage of any kind. The site remained a blank spot on the map for many years, while researchers tried to guess its true purpose. It was a puzzle that did not fit neatly into the established history of the region. The true shape of Monte Sierpe only becomes clear when you get high up in the air. If you fly a small plane over the valley and look down at the hillside, the random pits suddenly snap into a deliberate pattern. The thousands of holes are organized into a strict grid that stretches across the rough land for well over a mile. From the sky, the hillside looks exactly like a giant barcode stamped directly into the desert. The band curves and moves with the natural shape of the mountain while maintaining a very specific width. Creating a perfect grid of pits across a mile of steep rocky land requires an incredible amount of planning and land surveying. The builders had to measure out exact spacing and maintain straight lines without the aid of modern mapping tools. Digging out the rocky dirt and lining 5,000 individual holes with stones took tens of thousands of hours of intense work. The workers had to carry the lining stones up the steep hill by hand to ensure the sandy walls of the pits would hold their shape. A major breakthrough in understanding the site happened recently, thanks to a team of researchers at the University of Sydney. The archaeologists realized that studying the pits from the ground was severely limiting their understanding of the overall design. They brought in fleets of high-tech drones to map the entire Pisco Valley from above. The drones flew back and forth over the band of holes, taking thousands of high-resolution photographs from every possible angle. These detailed images were then fed into powerful computers to create a flawless, three-dimensional model of the entire hillside. The computer programs allowed the researchers to digitally strip away the modern desert brush. They were finally able to measure the exact depth of holes that had filled with sand over the centuries. When the researchers looked closely at the finished digital model, the drone mapping revealed strict mathematical patterns in the layout. The holes are not just a uniform grid stretching endlessly across the hill without variation. They are actually divided into groups and deliberate, carefully measured clusters. The spacing between certain blocks of holes changes deliberately at key points across the mile-long stretch. Some sections feature rows of exactly 9 holes, while others shift into distinct blocks of 12 or 20. The drone mapping proved that the builders were not just digging random pits in the sand. They were actively encoding complex numerical data directly into the landscape itself. The entire hillside was designed to store and display mathematical information on a scale that is hard to fully grasp. The grouping of the holes immediately reminded the researchers of a well-documented ancient recording tool. For thousands of years, cultures in South America used a complex device called a quipu to record information. A quipu is a collection of colored strings covered in very specialized knots. The placement and style of the knots represented numbers, dates, and regional inventory counts. The drone data showed that the layout of Monte Sierpe closely mirrors the structure of a giant quipu. The ancient builders literally carved a landscape-sized accounting book into the side of the mountain. Translating the concept of knotted strings into a mile-long grid of rock-lined pits shows an incredible level of societal organization. The different clusters of holes likely represented different categories of goods or units of measurement. An administrator standing at the top of the hill could look down and visually read the data stored in the grid below. Seeing this ledger carved into a desert hill forces researchers to rethink how advanced early record-keeping systems really were. The final piece of the puzzle came from looking at the microscopic evidence left inside the dirt. While the holes were completely empty of human remains, the soil tests revealed traces of ancient plant material. Archaeologists found high concentrations of corn pollen and the broken remains of woven reeds inside the stone-lined pits. This organic plant evidence combined with the strict mathematical layout points to a specialized use for the site. The entire hillside likely operated as a regulated barter market for the surrounding region. Farmers and traders traveling through the harsh Pisco Valley would bring their goods directly to Monte Sierpe to do business. The different groups of holes served as standardized measuring units for different types of crops and building materials. A trader could fill a pit with corn to establish an exact unit of volume before trading it for woven reeds or coastal fish. This ensured that no one was cheated and that all trades followed a strict, visible regional standard. The administrators used the layout of the grid to track the flow of goods moving through the valley. Thousands of people would have gathered at the base of this hill, turning the quiet desert into a bustling center of ancient commerce. It was a giant physical spreadsheet designed to regulate the local economy with absolute precision. Excavation data suggests the site was originally built by an older local culture before being taken over and expanded by later societies. Traveling inland from the dry coastal desert means a long climb back up into the high Andes Mountains. If you follow the winding path of the Urubamba River, you eventually reach the Sacred Valley, where the air cools and the land turns a bright green. Carved directly into the side of a steep mountain, here sits the sprawling ancient site of Ollantaytambo. It serves as both a farming center and a heavily guarded outpost watching the river below. The green farming terraces climb the steep side of the mountain like a giant staircase leading straight up into the clouds. If you climb all the way to the top of these terraces, you reach the main building area of the ruins. Sitting at the peak is an unfinished section known as the Temple of the Sun, which holds some of the most unusual stonework in the region. The main feature of this temple is a wall made of 6 giant stones standing upright side by side. These standing blocks are carved from pink volcanic rock, and they completely take over the visual space of the ruins. The bright pink color of the stone stands out strongly against the dull gray and brown mountain rock surrounding it. The size of these pink stones naturally makes researchers question how they actually got there. Survey data shows the largest of the 6 standing stones weighs roughly 50 tons and stands nearly 14 feet tall. To secure these gigantic slabs, the builders placed long vertical strips of stone between each block to lock them tightly together. These thin pieces of rock act as brilliant shock absorbers for the massive wall. When the ground shakes, these thin buffers absorb the friction between the 50-ton blocks and stop them from cracking against each other. This design shows a complex understanding of earthquakes built directly into the religious architecture. The builders knew the stress points of the mountain and designed the wall to bend without breaking apart. But the biggest mystery of Ollantaytambo is not just how the wall was designed, but how the rocks actually reached the top of the mountain. Geologists testing the chemical makeup of these standing stones discovered that the pink rock does not exist anywhere on the mountain where the fortress sits. To find the original source of the rock, you have to look across the valley to an entirely different peak. Archaeological surveys track the pink stone back to a quarry called Cachicata, which sits high up on the opposite side of the river. This distance turns the temple from a basic building project into a massive puzzle. The ancient builders did not just shape the stone, but transported it across one of the most difficult landscapes in the Andes. Getting these blocks out of the distant mountain is a huge physical hurdle before the travel even begins. The rock is rough and hard to cut, which requires vast amounts of labor to shape into clean blocks. The quarry face at Cachicata shows flat cuts where the rock was broken into large working blocks. Early excavation reports suggest workers may have used harder river stones to slowly pound the rock out of the mountain. Once the stone was finally cut free, the workers faced the immediate challenge of getting it down a steep mountain slope. Gravity is the biggest problem when moving a block of dense rock down a sharp hill. If a 50-ton stone gains even a little bit of rolling momentum, it will speed up and smash into pieces at the bottom of the valley. Controlling the downward slide of a solid 50-ton rock requires a massive braking system that can handle immense stress. Thick ropes made of woven plant fibers can easily snap under the sudden shifting weight of a falling rock. Dragging the stone over dirt and gravel creates intense friction that generates extreme heat along the bottom of the block. Using wooden sleds or logs as brakes on a steep downhill run requires very careful handling to keep the wood from splintering under the extreme pressure. The evidence shows the stones reached the valley floor completely intact, which points to an organized and successful plan. Getting the stone down the mountain was only the first part of this long journey. The workers then had to move the large block across the valley floor and confront the Urubamba River. The Urubamba is an active body of water prone to seasonal flooding and fast-moving currents. Moving 50 tons of focused weight across a moving mountain river is a major problem for any building team. Researchers have studied several different models to try and explain how the stones crossed the water without sinking into the soft riverbed. Some researchers suggest the ancient engineers built temporary dirt dams to completely move the river around the stones. Moving a fast river requires hauling hundreds of thousands of tons of dirt to create a watertight seal while the stones are pulled across the dry bed. Another studied theory suggests the use of rafts made of bundled reeds and thick wooden logs. Building a wooden raft capable of holding 50 tons of weight without sinking requires a perfectly balanced structure. The raft would need to be incredibly large to keep the volcanic rock from dropping straight to the bottom of the river. Even if a wooden platform was built, the fast-moving currents of the Urubamba create sideways pressure. Thick anchor ropes and organized pulling teams on both sides of the river would be needed to keep a loaded raft from floating downstream. The demands of simply crossing the water highlight the incredible organization needed to build the temple. After crossing the river, the workers faced the most punishing phase of the entire building operation. They had to drag the 50-ton stones out of the valley basin and up another steep hill to the final building site. Topographical maps of the fortress show the ramp leading up to the Temple of the Sun sits at roughly a 45-degree angle. Pulling weights uphill requires fighting the direct downward pull of gravity every single inch of the way. The amount of human pulling power required just to keep the stone from sliding backward down the ramp is hard to fully grasp. Engineering models often look at the use of packed dirt ramps and wooden rollers to ease the friction of the uphill climb. While this is a logical idea, it places extreme stress on the materials being used under the rock. A 50-ton block concentrates its immense weight onto a very small surface area on the ground. If a block is pulled over round wooden logs, the focused pressure can easily crush the wood straight into the dirt. Pushing tens of thousands of pounds of raw stone up a dirt hill also causes the soil to compress and shift under the extreme weight. The block can dig deep holes into the ramp, creating a wall of dirt right in front of the stone. The workers would have to constantly repair the ramp's surface while holding the boulder in place to stop it from sliding down. The sheer effort of organizing hundreds of people to pull perfectly timed ropes on a steep rocky hill requires intense local control. We have a very clear picture of this process because the builders left behind a trail of evidence showing their exact route. The path stretching from the high quarry down to the river and up to the fortress is scattered with abandoned blocks of pink rock. Locals and researchers call these giant, stranded rocks weary stones. There are dozens of these blocks sitting randomly in fields and resting half-buried on the steep hillsides today. These gigantic blocks serve as a frozen archaeological picture of ancient transport pushed far past the breaking point. The weary stones are incredibly important because they show the exact places where the transport system broke down and failed. You can see blocks resting near the edges of the Urubamba River where crossing attempts likely failed under the heavy weight. You can find other large stones left halfway up the final dirt ramp where the workers simply stopped pulling them. The sheer amount of abandoned material proves this was a very hard process that required constant problem solving. The sudden stop of work at the Kachi Kata quarry and the messy trail of dropped blocks provide a vital clue about the history of the site. It suggests a highly organized building project was abruptly halted before the temple could be finished. The Temple of the Sun itself remains noticeably unfinished, with raw stones scattered across the main flat platform. Archaeological evidence points to the site being abandoned quickly rather than slowly fading out over several generations. This sudden stop leaves us with a map of the exact methods and limitations of the ancient builders. The presence of the pink rock also raises interesting questions about material choices in ancient building. The workers chose to pull the heaviest stone from the most difficult location possible across the river valley. They elected to carve pink, volcanic rock from a distant mountain instead of using the abundant gray rock sitting right next to the fortress. This tells us the specific type of stone held a functional or cultural purpose that made the grueling transport nightmare completely necessary. Dragging a weighty stone across a river valley is an astonishing achievement. But once a building team actually manages to pull a giant rock to the top of a mountain, they still have to figure out how to build a wall with it. To see exactly how early societies shaped and fitted their stones, we can look at a sprawling site sitting high above the ancient city of Cusco. Taking the steep winding road up from the main square brings you to a wide flat area standing over 11,000 feet above sea level. This is Sacsayhuamán, and it is a place that immediately shifts our focus away from moving rocks and directly into the complicated puzzle of putting them together. The most striking feature of this huge plateau is a series of three-tiered walls stretching out in a distinct zigzag pattern across the grass. The sheer size of these walls makes you feel incredibly small as you walk along the dirt path at their base. The zigzag layout creates a series of sharp shadows that shift dramatically as the sun moves across the bright Andean sky. Every single angle of this site was planned to dominate the landscape and create a large barrier on the mountain. But the true wonder of Sacsayhuamán is found by walking right up to the face of the walls and looking closely at the individual rocks. The timeline of when this megalithic site was actually built has been studied by researchers for many decades. Standard history books usually say the famous Inca Empire built the fortress during the 15th century. However, recent testing of the soil layers buried beneath the walls reveals human activity going back much further in time. Carbon dating places the earliest building phases during the time of the Kilki culture, who lived in the area from roughly the year 900 to the 1200s. Archaeologists digging into the dirt have found distinct layers showing the site was built and changed in phases over a very long time. The Kilke were a clever farming society that changed the local landscape long before the Inca arrived to claim the capital city. They laid the groundwork for the terraces and foundations that later empires would eventually build upon and expand. Finding their historical footprint beneath the fortress shows that Sacsayhuamán was a valued location for many centuries. The newer groups simply built their smaller and more uniform walls directly on top of the giant stones left behind by the very first builders. Those lowest foundation stones represent the oldest part of this long history, and they present a puzzle for modern researchers. The original builders used specialized techniques to construct the main defensive layers of the fortress. Instead of cutting the stones into straight and uniform rectangles like modern bricks, they carved them with multiple strange angles. Every single rock is custom cut to fit perfectly flush against its neighbors, locking together like a giant three-dimensional puzzle. There are no straight lines or predictable shapes anywhere in the lower walls. The builders allowed the natural organic shape of the rock to decide the overall flow and look of the structure. The sheer volume of stone fitted together on this plateau requires a staggering amount of raw material and careful planning. The largest foundation stones at Sacsayhuamán stand over 28 feet tall and represent a surface area that must sit perfectly against the next block. Fitting two small bricks together is a very basic skill, but getting a perfect fit across a 20-foot surface of raw limestone requires extreme focus. Any slight mistake in the angle of the cut would leave a visible gap between the rocks. Yet, the ancient builders maintained a perfect seal from the top of the wall all the way to the bottom. The joints between these multi-angled stones are so incredibly tight that a piece of paper cannot fit between them. This perfectly flush connection goes into the core of the wall itself, rather than just looking good on the outside surface. Achieving this level of fit with stones weighing dozens of tons requires a complex understanding of space and shapes. The builders had to calculate the exact inside and outside angles for every single block before locking them into the greater structure. Because the stones lock together at strange angles without the use of any cement, they create a structure that is incredibly tough. The Andes mountain range sits on an active zone that experiences frequent and violent earthquakes. These natural events can easily destroy modern concrete buildings that rely on stiff cement and rigid steel frames. When the ground violently shakes at Sacsayhuamán, the interlocking stones are allowed to shift slightly and absorb the friction. The stones essentially dance during an earthquake and then settle right back into their original perfect positions once the ground stops moving. Planning the distribution of weight inside a wall like this is a complicated balancing act. Because every stone is cut at a different angle, the downward pull of gravity is spread unevenly across the entire structure. The builders had to know exactly how the weight of a huge upper block would press down on the multiple smaller blocks sitting directly beneath it. If the angles were cut incorrectly, the focus pressure would crack the lower stones and eventually collapse the entire section of the wall. This indicates the early architects deeply understood load-bearing physics and structural weight long before the use of modern computers. It is a brilliant building solution designed to keep the walls standing for thousands of years without needing constant repair. The main debate among researchers today focuses entirely on how the ancient workers actually achieved these perfectly flush joints. A widely studied idea suggests that workers simply bashed the edges of the giant limestone blocks with smaller river rocks until they fit together. When modern researchers test this traditional method of pounding limestone, it creates cracks and impact craters in the material. Hitting stone with another stone breaks the outer layer and leaves a rough and uneven surface. This reaction does not match the glass smooth and perfectly flush joints spanning over 20 feet that are preserved at the site today. To get a perfect flush, using the bashing method, a worker would have to lift the boulder into place to check the seam. Then they would have to completely remove the rock to slowly sand down the high spots before lifting it again. Repeating this process hundreds of times for a single stone using only human strength presents a severe challenge. The smooth, interlocking corners required a level of standardized shaping that goes far beyond simple physical pounding. The ancient stoneworkers clearly possessed a method for slicing through dense rock that leaves no primitive tool marks behind. Walking along the surface of the walls, you can search for the normal signs of scraping or chiseling found at other ancient sites. A typical ancient stone wall is covered in scratches where metal or stone tools bit into the rock to shape the edges. The giant stones at Sacsayhuamán lack these basic mechanical scars, entirely offering very few clues about the tools used to cut them. The surface feels almost smooth to the touch, with slightly rounded edges that bubble outward toward the viewer. The rock looks as though it was molded or softened into place, rather than chipped away by thousands of hammer strikes. What makes this puzzle piece style of building so fascinating is that it appears in several completely disconnected ancient cultures. We see this exact same stone fitting technique scattered across the globe in locations separated by vast oceans and thousands of years. You can find walls with the exact same flush and multi-angled joints at the Valley Temple in Egypt and forming the foundations of the Imperial Palace in Japan. The sheer math required to cut and fit multi-angled stone blocks makes this shared building style a profound global mystery. Seeing this exact same technique on Easter Island and in the Mediterranean forces researchers to ask very difficult questions about ancient knowledge. Some researchers suggest this is simply a natural coincidence where different groups independently discovered the strongest way to build a wall without cement. But the design choices, such as the bubbling faces of the stone and the inward-leaning angle of the walls, are remarkably identical across these distant sites. It raises the possibility of a shared global knowledge base or a specific building technique that was passed down through ancient trade routes. The walls in Peru are simply one heavily concentrated piece of a much larger and older architectural puzzle stretching across the ancient world. The visible surface walls at Sacsayhuamán are really just a small fraction of the complex planning hiding at this location. In the years 2025 and 2026, archaeological teams conducted ground-penetrating radar scans of the entire Cusco region. These geological scans revealed hidden underground tunnels and structures buried far beneath the city and the fortress itself. The radar bounced off regular geometric shapes carving straight through the solid mountain bedrock. These scans provided proof that Sacsayhuamán is connected to a vast underground network that was heavily built up over a very long time. The radar scans also highlighted advanced drainage systems running directly beneath the main dirt plaza of the fortress. The original builders carved and carefully measured channels underground to direct seasonal rainwater completely away from the foundations. They actively changed the bedrock itself to control the water flow and prevent the walls from sinking into the resulting mud. The rainy season in the Andes brings an enormous volume of water that can easily wash away large structures if not properly managed. This shows a level of city planning that required an understanding of how water interacts with Earth over many centuries. The discovery of these hidden channels shifts the perspective of the site from a simple military fortress to a sophisticated water management facility. The Quilchi culture and the later Inca Empire placed a cultural emphasis on the control and worship of living water. Carving channels through solid bedrock to manipulate the water table shows an absolute mastery over the natural mountain environment. The scans suggest that the complex we see above ground is only the final layer of a building project that began deep inside the earth. It proves that the site was meticulously planned from the bedrock up rather than slowly pieced together over time. The tight and cement-free joints of Sacsayhuamán show us exactly how early builders achieved incredible structural strength by embracing the natural and organic shapes of heavy rock. But while fitting oddly shaped limestone blocks together is a brilliant display of geometry, it still relies entirely on the natural flow of the stone. To find an ancient society that abandoned organic shapes entirely in favor of strict and standardized precision, we have to look further south. Traveling hundreds of miles past the Sacred Valley takes us across the border into modern Bolivia. The tight mountain passes eventually open up into a vast, high-altitude plain sitting right near the edge of Lake Titicaca. The air here, at almost 13,000 feet, is incredibly thin, and the surrounding land feels harsh and barren. Scattered across this wind-swept dirt are the shattered remains of an ancient site that completely changes how researchers view early building techniques. This is Puma Punku, and it presents a mystery heavily rooted in material science and mechanical design. The ruins sitting in the dirt here do not look like the rough blocks found back in Peru. They look exactly like modern building materials designed to slide together perfectly on an assembly line. Archaeological records show these ruins belong to the Tiwanaku Empire, which was an organized society that ruled this region long before the Inca arrived. Recent high-tech dating methods have pushed the origins of these structures back to around the 6th century. The Tiwanaku were a sprawling culture known for their vast trade routes and complex farming systems designed to survive the freezing high-altitude nights. But the ruins they left behind at Puma Punku reveal a level of engineering that stands completely apart from their farming achievements. To understand the sheer scale of this site, researchers have to look closely at the materials the builders chose to work with. The foundation of the site is built mostly from large blocks of red sandstone, but the most intricate carvings are executed in a type of volcanic rock called andesite. Sandstone is relatively easy to carve, but andesite presents a completely different challenge for any stoneworker. It is a very hard and rough rock that quickly dulls and destroys basic hand tools. In modern construction, builders try to avoid cutting andesite entirely, unless they are using industrial saws coated in diamond dust. Yet the ancient builders of Puma Punku chose to use this brutal material to create the most delicate and precise shapes found anywhere in the ancient world. The most famous features scattered across the dry earth are known as the H-blocks. These are massive and interlocking slabs of andesite carved into complex modular shapes that look exactly like giant geometric letters. What makes these blocks so fascinating is the level of absolute geometric consistency carved directly into the hard stone. The lines are perfectly straight, and the flat surfaces are incredibly smooth to the touch without any rough patches or natural variations. The most complex engineering hides inside the cuts and grooves carved into the faces of these modular blocks. The architects achieved perfect and sharp inside right angles, inside the stone, where traditional tools barely fit. Achieving a perfectly sharp inside corner in solid rock is a tough specialized task that usually requires a drill bit or a modern cutting machine. If a worker tries to carve an inside corner with a hand chisel, the tool will naturally leave a slightly rounded edge, because the blade cannot reach the exact point of intersection. The H-blocks at Puma Punku do not have rounded edges in their interior cuts. The angles are razor sharp and completely uniform across multiple blocks sitting in the dirt. This level of standardized building suggests an organized factory process rather than individual artists randomly chipping away at rocks. The builders also left behind a series of perfectly drilled holes, running along the edges of the modular blocks. These are known as blind holes, meaning they do not go all the way through the stone, but stop at a calculated depth. They are drilled to exactly 6 millimeters wide, and every single one features a perfectly flat bottom. Drilling a flat-bottomed hole into hard, volcanic rock requires a drill bit made of a material much harder than the rock itself. Creating these holes also requires a mechanism capable of applying constant and even pressure to keep the drill from snapping or sliding off center. The accepted archaeological explanation suggests the Tiwanaku achieved all of this using nothing but basic copper chisels and small pounding stones. However, testing of this theory highlights several severe limitations when working with hard volcanic rock. Copper is a very soft metal that bends and loses its edge almost instantly when struck against something as hard and rough as andesite. If a worker attempts to drive a copper chisel into this rock, the tool will bend out of shape before it makes a significant dent. Several modern experimental projects have attempted to recreate the precise cuts at Puma Punku using the primitive tools found in the local dirt. Professional stone carvers have spent weeks pounding andesite with river rocks and scraping it with soft copper blades to test the limits of the tools. These tests have consistently failed to achieve the sharp inside corners and perfectly smooth faces found scattered across the site. The primitive tools simply create rough and uneven gouges and eventually break entirely under the constant stress. The complete lack of primitive tool marks on these precision stones has driven material scientists to look for completely different explanations. A standard ancient stone wall is usually covered in scratches and impact craters, where hand tools slowly bit into the rock over time. The stones at Puma Punku lack these basic mechanical scars, entirely offering zero evidence of a traditional carving process. This absence of tool marks recently led a team of researchers from France and Peru to propose a radical new idea. These researchers suggest that the ancient workers might not have carved the hard volcanic stones at all. Instead of cutting the rock, the scientists proposed that the ancient engineers actually cast the blocks using an advanced chemical cement. This theory suggests the builders ground up the local volcanic rock and mixed it with a specific chemical binder to pour it into perfect geometric molds. To test this idea, the scientists looked at samples of the Puma Punku rock under advanced microscopes. The microscopic scans revealed traces of organic plant matter trapped inside the solid stone itself. Natural volcanic andesite forms under extreme heat deep inside the earth, which completely burns away any living organic material. Finding organic plant matter inside the rock strongly suggests the material was mixed by human hands on the surface in a wet and temperate environment. This chemical evidence means the Tiwanaku may have invented a natural mixture that allowed them to cast solid rock, just like modern concrete. Pouring liquid rock into smooth wooden molds would explain the sharp inside corners and the uniform shapes of the repeating H-blocks. Casting the stone also provides a highly logical explanation for how the builders achieved glass-smooth flat surfaces without leaving a single metal chisel mark behind. If they were casting the stones, they could easily insert small wooden sticks into the wet mix to create the perfect 6mm holes. Once the rock hardened, the sticks could be removed, leaving behind perfectly flat-bottomed blind holes without the need for advanced mechanical drills. This pouring process completely removes the need for diamond-tipped tools or soft copper chisels that bend against the hard stone. Inventing a complex chemical recipe to dissolve and recast volcanic rock requires a learned understanding of material science. Recognizing that a 6th century society may have utilized advanced geological cement fundamentally changes how researchers view the timeline of human technology. It indicates that early civilizations were conducting complex chemical engineering centuries before the modern industrial era began. The ruins themselves add another confusing layer to this mystery because the site looks like it was subjected to a large-scale disaster. The interlocking blocks are not standing in neat rows, but are tossed around the landscape like small wooden toys. It looks as though a wave of water or a sudden explosive force ripped the entire complex apart in a single instant. Archaeological evidence shows exactly where the original builders linked these stones together to create earthquake-resistant walls. They carved small geometric grooves into the blocks and poured molten metal directly into the stone to act as connective clamps. Pouring molten metal into solid rock requires portable smelters and an incredible control of extreme heat right on the building site. But those metal clamps were violently ripped out of the stone long ago, leaving behind nothing but empty connecting slots. To see this, we have to travel back into the high Andes mountains of Peru. Deep inside a remote and freezing mountain valley sits a site called Chavín de Huantar. This ancient complex sits over 10,000 feet above sea level, exactly where two fast-moving mountain rivers crash together. Archaeological dating shows the site was built and expanded between the years 1200 and 400 BC. This timeline means the complex was built over 2,000 years before the famous Inca Empire ever existed. When Peruvian archaeologist Julio Citello first began digging up the site in the 1920s, he recognized it as one of the oldest major cultural centers in South America. From the surface, the main temple looks like a fairly standard ancient ruin that blends naturally into the rocky background. Visitors walking the grounds today see a large, flat dirt plaza surrounded by stone walls and stepped platforms built right against the mountain. The builders used local granite and limestone to construct the visible outer walls and decorated them with large stone heads carved to look like local wildlife. Early excavation reports focused heavily on these surface carvings and the simple pottery found scattered across the farming terraces. But those surface ruins are really just a structural roof covering the true marvel of the site. The most complex architecture at Chavín de Huantar is completely hidden out of sight beneath the dirt plaza. Finding the actual core of the temple requires walking past the main outside walls and climbing down through narrow stone entrances into the earth. The underground portion of the complex consists of a network of connected stone hallways known as the galerias. These narrow pathways are built from huge slabs of rock that completely block out all natural sunlight and silence the wind blowing across the surface. The temperature drops rapidly as you move further away from the entrance and deeper into the cold stone belly of the mountain. The pathways twist and turn in confusing patterns designed to disorient anyone walking through them. Modern researchers who study how the environment affects the brain call this kind of underground layout a sensory deprivation space. When you take away all natural light and surface sound, the human mind struggles to figure out basic directions. The ancient architects designed these dark hallways to strip away normal input so they could introduce something far more powerful. They built the stone temple above to act as an amplifier for a highly specific sound. To achieve this sound, the original builders had to finish a water management project before building the temple walls. The site sits exactly where the Huachexa and Masna rivers violently crash together in the valley. The ancient workers altered the natural path of this rushing water and forced a large portion of it to run directly underneath the main complex. They carved a complex network of water channels through the solid mountain rock directly beneath the underground stone maze. Controlling a mountain river is incredibly dangerous work because sudden seasonal flooding can easily wash away a building site entirely. Moving a fast river is a challenge that requires an intense understanding of water pressure. The ancient builders managed to redirect this water flow using only raw stone and organized human effort. They did not just build simple pipes to keep the underground basement dry from the mountain rain. The underground water channels are made with drops and narrow stone choke points designed to deliberately restrict the water flow. As the river water rushes through these channels, it pushes the air inside the tunnels and creates a vacuum effect. The work required to dig these water channels underneath an existing mountain structure is hard to fully grasp. Workers had to move through freezing water and chip away at solid rock in almost total darkness to form the drainage network. They had to constantly check the water pressure to ensure the tunnels did not flood completely and drown the carving teams. They achieved a calculated balance of air and water flow that kept the tunnels from filling up while still creating the needed vacuum pressure. This rushing water creates a low humming sound that travels straight up through the thick stone floorboards of the maze. If you are standing inside the pitch-black hallways, you cannot see the water, but you can feel it vibrating the solid rock under your feet. The shape of the water tunnels is tuned to produce a very distinct noise that echoes heavily through the dark corridors. To anyone trapped inside the maze, the entire building literally sounds as if it is growling like a wild cat. The sound bounces off the tight stone walls and hits the listener from every possible direction at once. The sound energy is so strong that it actually vibrates inside the human chest and completely overwhelms the senses. Recent studies conducted by acoustic researchers have looked closely at the sounds generated by the rushing water at this site. They discovered that the low vibrating hum produced by the water canals directly changes human brainwaves. The pitch of the sound matches the exact audio level required to alter human consciousness and create a deep trance. The architects clearly understood how sound affects human biology, and they built a mountain-sized instrument to trigger those reactions. The leaders of the Chavín culture used this dark and roaring maze to initiate new priests and hold significant influence over their society. They used the natural environment to prove that their religious authority was an undeniable force. Historical evidence suggests a new initiate would be given strong local plant mixtures before being sent down into the freezing dark maze completely alone. The total lack of visual light, combined with the vibrating roar echoing from below, would cause a shift in their perception of reality. The building was designed to break down the normal human baseline and rebuild it using nothing but architecture and targeted sound. The initiates would wander the dark stone halls for hours. When they finally walked back out into the bright mountain sunlight, their worldview was forever changed by the intense psychological journey. Deep in the very center of this confusing maze sits the final destination for the initiates navigating the dark. The builders placed a 15-foot-tall stone carving exactly in the middle of a cross-shaped intersection of the main underground hallways. This giant spear-shaped stone is known to researchers as the Lanzon monolith, and it is covered in intricate carvings of fanged faces and twisting snakes. It served as the ultimate climax of the auditory journey, designed to permanently burn the imagery of the temple into their minds. Building a giant instrument of this scale requires a complex understanding of how water moves and how sound travels through solid material. The architects had to calculate exactly how much water was needed to push the air just enough to hit a specific hum without destroying the foundations. If the water channels were carved just a few inches too wide, the sound would simply escape, and the entire audio effect would fail completely. The math required to balance the immense weight of the temple above with the rushing water below shows a profound level of early planning. It demonstrates that early societies were actively experimenting with water pressure and environmental control centuries before similar ideas appeared in other parts of the world. The exact methods they used to carve the bedrock and precisely tune the water channels remain a subject of ongoing archaeological study today. When the Spanish eventually arrived in the Andes, they found the underground maze completely abandoned, and its original purpose was lost to the local populations. The engineering required to build a giant water-powered sound machine was completely forgotten in the harsh environment of the mountains long before European contact. The incredible structure sitting underneath the dirt plaza simply became another quiet ruin buried in the high-altitude landscape.